Hello, people. What's going on? All right. It's been a little while since I've done a stream. And it's been a little while since I've worked directly on the compiler because I was working on the game for a while. So some bugs reported by people are backlogged. There's about 12, I think, or 13. Anyway, they may not all be bugs that I'm going to fix. I may not get through very many tonight, but I just wanted to do a little bit. I just wanted to, start up and do something. So, what we've got going on here is a test case that somebody made, or, they hit a bug and they made a repro case. And things are trying to patch, and the error message is not good. It's not telling us what, so that's a problem. But that's not so bad because this is not necessarily an error that end users are ever supposed to see because it's an internal problem. And it looks to me like what's happening is, assert has a static if on get field. And although, what happens if I change this? Before I say what I think it is. Yeah, so that's the same. Okay. Good. Let's use the simpler code. Whoops. Wait, what? How did I? That's like a syntax error right there. Oh. Right. Okay, so it is the same problem. All right. So, assert is trying to do a static if, and it's trying to check for this field being on the context because you can add or remove fields from the context in your program. And if it exists, then we call it. This guy tries to call assert from the body of his procedure. Now, in theory, this should be fine. Wait, no. No, actually, no, it's not fine, right? Because this needs to run at compile time. And it can't because it needs to call this, the body of which can't exist until this runs at compile time. So actually, our real problem is that this is buggy end user code. So the real problem is we're saying internal compiler error instead of telling people, hey, this is a legit circular dependency that you can't do. And of course, you can be arbitrarily high quality about how much work you put into communicating the exact error to people. And we'll do a lot of that eventually, but we're going to rewrite the dependency system before we do that. So for now, I'm going to settle for detecting the situation at all and telling people anything about it. And then later we'll work on making it good. Does that make sense to anybody? Make sure I'm not still broadcasting on Discord. All right. Well, nobody's asking questions about that. If I stream tomorrow, will it be an April Fool's stream or an Easter Sunday stream? Good question. I don't know. You loved Mark Brown video on my game design philosophy. I don't know which video that is. I don't tend to watch stuff about me because that's weird, so I just let people do what they're going to do. Okay. Well, so I think one possible issue is that if there's a loop in patch, it just always says internal compiler error, because I assume that could never legitimately happen. But it certainly could with compile time execution. How are there 357 quotes? That's too many. You've been working on your own compiler and have no idea how I did compile time execution. Does the compiler build a program that does operations on an AST data structure, then pass that into the compiler again? No. No. So we parse into an AST. We figure out all the type information for all the operations in the AST. We convert to a bytecode internal representation. And then we just have an interpreter for that. Or we compile past that stage to machine code, right? We have sort of two directions to go from there. It's really straightforward. You don't want to try to execute an AST. It's not good, because the problem with that is you end up probably writing a recursive thing. The most straightforward way to do it would be to write a recursive thing that walks around the AST. And the problem with that is that then your interpreter's control flow is too tied up with the tree itself, and that causes a lot of problems. So I don't know, you tend to make more of like a machine with an explicit stack or something to have more control over things. It's just not the right way to do it, though. Oh, that one. I actually did see that video. Yeah. I have some issues with it. But I think if it's the one I'm thinking of. Oh, no, it's not. I'm thinking of a different video. Never mind. Never mind. Okay. Well, let me just at least find the site. It's been a long time since I've looked at the code that does this. So, where is this? Let me move my Visual Studio so that you guys can see it. What? What's the error message? Stuck in queue. Okay, it's in me. Great. Right. So this is called report undeclared identifiers, but oh, come on, C++. They're working on all these fancy things for IntelliSense to do, and they can't even jump to the definition still half the time. It's 2018. God damn it. I just wanted to drag the window. Why is this only 5 lines? Oh, okay. Whatever. Okay. Yeah. What progress has been made since the previous stream? Little bug fixes mostly. There's been no big features. I spent a lot of my time working on application programming, which is important to make sure that the compiler is on the right track and that you know, that it can handle what we throw at it. Okay. Now, so this thing flattens out all the dependencies only in the infer pipe. All right. So how about if I did do this? I'm going to break here. And I just want to make sure that the contents of pipe patch, whoops, I want to make sure that the contents of pipe patch look like what I think they probably should, which would be, you know, I don't think we need that wide of a camera angle, do we? So I can figure that. All right. Now it's very easy for me to duck out. But when can you use it to build a Hello World program? I don't know. I don't know why you would want to do such a thing. Okay, so report undeclared identifiers. And then we will not have done that. So let's set the options. We're on bug 103. Okay, this is false, right? So what does stuck pipe say? got one item in it. Okay, and it's waiting on two things. Come on, man. It's such a weird interface. You drag it an arbitrary distance, and then it'll make a new thing. Okay, so these are the two things that we're waiting on to patch. One of them has no identifier name. The other one is the identifier bool. What? That seems very strange. Oh, but it's further. It's in the next pipe. Stuck pipe arrow pipe flags. I forget what it's called. Pipe in. It's just this. It's 64. So this one doesn't have that bit set. So we don't care about that. We're only actually waiting on this one because that has this bit set. 192 is 128 plus 64, right? So this is waiting on a lambda, right? And that lambda has dependencies. So what do? I'm going to start making an error message for this specific case. It's going to say things aren't able to run, possibly, or things aren't able to build, possibly because of either a static if or a run directive or something. And then we'll say. So the guy that we're waiting on let's look at it. So he's waiting on 4 things. I don't know. It just starts to get tiring to go through this. Like, we can report one level of what we're waiting on. Like I said, the dependency system is going to change. So, you know, my goal right now is just to give us enough information to let people know kind of what's happening. All right. Yeah, the chocolate fish is pretty fly. How does it create a context without SDL GLFW? I'm confused about the questions in chat. I don't know what you guys are talking about. All right. So here we're going to say, if we're in pipe patch, else, we're going to say, refactor, move this into explain. Well, now we'll do that. So I have this explain, which is supposed to be about giving explanations for error messages. And it's got things like printing single dependency and all that. So now I'm going to use that. Okay, so explain patch loop. So we're going to do this. Explain is explain patch loop. Where is it? Yeah. And then, if it was not explained, we do some stuff. All right. Ooh, loud. Okay. Explain patch loop. Identifier not found. I guess that doesn't include explain.h. What is my take on Rust as a general purpose systems language? I've said that many times, and I don't want to keep repeating myself, so someone can point you at a rant or something. I think Rust is too high of friction to be a general purpose engineering language. It might be fine for select very high security programs. Okay. I'm just going to make sure that I'm doing the right thing. So here I'm just going to say, report error. Well, we'll put this in here. This procedure cannot be compiled, cannot complete compilation, code cannot be generated for this procedure, possibly because of a leap involving compile time calls, for example, with if or run. Okay, we're just going to do that. Yeah, I mean, we'll do it more in a second, but we're starting slow. Today's a slow day. Okay. Okay, great. Now, let's put run first, if second. Now, well, So if the pipe flag, let's just say if it's not set. Explain print. I don't know if that'll be enough information. Print single dependency. I don't know how to print a dependency. Print single dependency. arg2 dependency to. I don't know why we have those by value. Actually, yes, I do. Okay. Is that enough information to? Not really. That is not very helpful. Wait, do I have to print a new line there? Whoa. Why is it printing out such a mess? Well, okay, let me try using the explainer stuff that I already wrote. Let's try doing this. Let's see what happens. Nope. Nope. Get all explainer dependencies. That should so what this explainer dependencies thing does is the dependency system is kind of complicated at this point, and there's different ways that things can depend on other things. And for the purpose of writing nice error messages, it just helps to translate it out into a more uniform way. going to see $402. Okay, well, it definitely found things. Okay, now I have to download the stupid tool again. Graph is .file viewer. Download executable packages, Windows. Why do you make me work so hard to figure out what to download? Okay, so that's there. There's no way to get a shell in Windows to update your path, right? Like I literally have to do a new one. I have to put it in my path because the installer certainly does not want to put the program in your path. Open source people. Every time I installed, I probably already had it installed and didn't know because it's not in my fucking path. Every single person has to do this. All right. Environment variables. All right. Maybe there's a checkbox for it. And I just didn't see the checkbox. It's possible. I'm going to run the installer again to see if there was a checkbox that they didn't check, in which case, why isn't it checked by default? Let me see. Oh, no, it's not going to give you the same UI. Never mind. I'll watch the stream. So, hey, guess what? I get to run and open a third shell. Dot. It's still not recognized. What the hell's going on? Oh, it's what? Oh God. Okay, so just quit it all out. Start a whole new one. God. All right. It's just stuff like this wastes so many. Like multiply this last 5 minutes by 10,000 at least, right? That's how many people's time has been wasted on a stupid thing. This is why computers are so bad. All right, now I got to get back all what I was doing. Let's try photos. I don't know. Hey, look, it's an empty bitmap anyway. Great. Spent 5 minutes to figure that out. All right, well, that was a giant waste of time. Except that we learned that we're not outputting anything, which is weird because we have 402 nodes. Yeah, it's literally empty. So what's going on there? What's going on is we're filtering all of these out for some reason. Printing the cycles. And we're not seeing any. Maybe I should add something that raw dumps the nodes. Why am I not seeing the cycles? See, the thing is, if you dump everything that's not compiled yet, you'll mostly get junk that is not the source of the problem. The reason why we're detecting cycles here is to, try to give you what's going on. Now, we should have a cycle, and we don't seem to. So I'm not sure why. I'm not sure if we're filtering it out for some reason, or if we're not adding the appropriate things for some reason. Yeah, someone linked that XKCD. Yeah. All right. This is when a problem turns into a deeper problem that I'd rather not solve. Like, I'd rather just make this a short stream and go play PUBG, honestly, but I want to fix this error message. And it has turned from identify the problem to the user into figure out why we're not getting any output from this abstract graph operation, which is a very different thing. Okay. Here's what we'll do. If we don't get any cycles, this is going to be a fallback thing anyway. Detect a cycle. I'm going to return bool. Okay. So here we're going to say printed is that. If not printed, we didn't print anything and we had nodes, I'm going to say strangely, we did not find a cycle. I'll make that an internal compiler error for now. And then for nodes, it print out index is 0. I don't know. I don't know if that was exactly the right thing, but okay, we got a thing. The graph is too large for Cairo render. Okay. This is not helpful. Do I have Photoshop installed? No. Well, it's just a giant. Oh, and of course it's scaled down because their Cairo bitmap renderer cannot possibly handle how wide? I don't know. It can't so it draws this text and then it scales down the text to unreadable. All right, well, it's a bunch of things with no connections between them for some reason. Probably all things that are irrelevant. I'm really in a bad mood about this now. Graph is too large for Cairo renderer, but it's my butt. Oh my god, people. The thing is what, 400 wide? I mean, maybe it's what, 100 pixels each? It can't output a 40,000 pixel wide bitmap. Something like that. I don't know. All right. So it's just a bunch of like singleton nodes. So this doesn't really solve the actual problem or answer any question relevant to the actual problem. The actual problem being, why are we not finding a cycle, right? Like if I step through, oh, you know, I'm going to break there and I'm going to manually step through because I have the feeling that, so what's going on? We've got assert wants to go into pipe patch. It depends on a couple of things. Let's look at the code. So, you know, this is not able to compile because it's got a static if. I don't remember if it's got a dependency. It probably has a dependency on the static if, which will then have a dependency on a run directive. Which will then well, yeah. Rather than dumping it into a generic routine, let's just go back to here and it's depending on the lambda. The lambda is probably the implicit lambda here that this static if is waiting on. Let's see. It's line number 15. 15. Oh, no, it's waiting on its Okay, this is where things get annoying. This thing is I'm tired today. Okay, queued flag is 16, which I think means it's a header. Okay. Yeah, header is 16, body is 32. So this is the header, and headers depend on their body to patch. So this dependency that I'm looking at is not even the right one. So the header is waiting to patch. It is depending on the body. Okay, so the body here also has dependencies. Wait. That's a no op, right? Okay. Yeah. So, right, this is the guy who had the 4 dependencies. So my hope, oh, and he also has sleeping on and all that. Who's he sleeping on? What? Sleeping on a run directive. But the run, what? Okay. This is bananas. Now I'm just confused. This shouldn't have passed anywhere, right? Line number 16, right? So, Emacs, jump off a cliff. Right, so, when you have a static if and you have a complex expression here, essentially it's shorthand for this. There's an implicit run directive here because this is not a constant expression, but it's probably verbose to have to say this all the time, right? So we make an implicit run directive. Now that run directive calls get field, and get field wants to call assert and can't, but the run directive still claims to be in pipe output C, which means it ran, which is confusing. If it said it was stuck in an earlier pipe, then I would be fine with that. I would just say, well, we detect that, and we tell them, hey, you're waiting on this particular run directive. Now the problem is, Now it's turned into a whole meta thing where it's like, oh, I have to go figure out why either this run directive is erroneously passing further through the pipeline than I think it should, or figure out why I'm confused. I don't want to figure out arguing with Dot right now. It's not going to help because it wasn't giving us any useful information anyway. All right, I'm going to get some tea for a second. And then I'm going to use that short break to clear my headspace and figure out how I want to approach this. This is rapidly turning into a nested problem. Nested problem. Right. I've got tea, and I've got Mozart candies given to me by a friend from Austria, these are apparently people there know what these are. It's like chocolate with marzipan inside. Apparently Wolfgang Amadeus Mozart really liked marzipan or something. Yo, those are famous. They're not, nobody in America knows what these are. Nobody in America has ever heard of these. I like this kind. I like the round kind better. That might have been the last one. I know I've got some more. The flat kind is not as good. Maybe if I eat enough of these, I will become a musical talent. Okay. Actually, they're both good. Both of these are good in different ways. Okay. So what do we do about this? I'm like 3 problems deep at this point. But you know what? That's okay. That's okay. I'm learning. I'm coming to understand more things about this system. And that's always good, even if it doesn't lead to solving anything that you thought you were going to sit down and solve right away. I'm getting things out of my pocket now. Okay. So my inclination now is maybe I just ignore the main goal for a while and just try to figure out what is going on with this run directive. Why, like, did it run? If it ran, how did it run? Because it shouldn't be able to run. And then I think it didn't run. And somebody erroneously, there are some like things that we did for performance reasons that bump things forward in the pipeline, and somebody probably bumped it forward for a wrong reason. I don't know. But like it never, okay, if it ran, it would have a return value. And I can look at it. See, my brain is starting to work. The Mozart candy made my brain start to work. Okay. It has no return value, so it never ran. So that by itself is bad news. So maybe I forgot something about how these work. Like, how is it in output C? If it got canceled, it could go there. Let me look at... Whoops. I don't want to cast that to a directive run. CBI sucks. Do what I say. All right. If this were DQ'd, it would have flags that are non-zero. The flags are 0. So, like, it legit somehow got to pipe output C. I want to know how this thing goes to pipe output C without... So I'm just going to look at every time this gets added to a pipe. We're going to breakpoint condition, Q, Visual Studio. They just make it worse every time. It's amazing. All right. So, well, now this is very slow because this procedure gets called a lot. Okay. So this is probably an earlier pipe. It's in the infer pipe. It's in the size pipe. Send messages. Hold for messaging. Build. Run. Output C. Who is putting this in output C? And why? If it's a run directive, I hate this interface. Why? Is there a toggle to change that back to be the way it used to win? like I looked for it and I couldn't find it, but like I would like it to work the way it worked in every Visual Studio before. All right, let's disable this. All right, run. Okay, so we're adding it to the list of run directives. Okay, the run directive itself, I see. The run directive itself goes in this run directives array. And that is probably the thing that we're not considering. So the node yeah, the node continues on to the end. Okay. But there's nothing in the run directives. So it got removed from there between, well, let's just see. Let's just see. So we're back here. Okay. Like this window, I open it and I can start typing, but the other one I can't. All right. So pickup directives. We pop and we call run bytecode, but it's not ready to run yet. So I guess it shouldn't have. Right, it's procedure. Oh no, it's procedure passed. What? I'm so confused. I am so confused. Somehow, this run directive's procedure passed. Okay. I'm super confused. Okay, this lambda is the run directive that was implicitly added for the static if. It I think I know what's happening. This is bad. This is bad. Do I know what's happening? Here's what I think is happening. So remember I said, because this isn't a constant expression, we generate a run directive that has this in it, right? That is true, that's what happens. The problem, I think, is when that happens, right? So what we're supposed to do is say, okay, we made a run directive and it's got this lambda, but this lambda is waiting on get field, and get field isn't callable. It hasn't passed the run pipe, so this lambda can't pass the run pipe, so the static if can't ever proceed. However, I think that the problem is the way dependencies get tracked. A major component of it is where identifiers are used. And I think that maybe because we don't create this lambda until later, these dependencies get put on assert, which means they don't get put in the right place. Or I don't know where they go. I'm not sure if this is accurate. It's just my theory. It's just my idea. Yeah, do I ever pace? Yeah, I pace when I wanted this to be a simple short stream, and it turns into not that. I mean, these things are good because, you wrestle with complexities like this, and it helps you figure out what to do better next time. So, like, I want to rewrite the dependency system again. What we're using right now is something like my third rewrite, so the fourth version of it. And it's going to get rewritten again. And, things like this inform the new design, if this is the actual problem. The problem is, it's been months since I've thought about this part of the compiler, so I don't actually know if that's the actual problem. It may be. It sounds like a major problem, yes. The question is it a major problem? Question is, what if I do this? Does this have a different result, or does it have the same result? I don't actually know. It has a different result. Yeah. So this is, okay. So normally you would get this circular dependency error. And this error is not that easy to decode, but we could probably compress it some and so forth. Like this header, depending on body, we could like elide that. Unhandled type, that's probably the run directive. Anyway, you can tell from this output, even though already this isn't super pleasant, you can tell from this output that it's something to do with get field and assert and circular dependencies, right? So you can sort of then know, okay, they're trying to call each other at compile time maybe or something. Like, that's not the greatest error message, but it's enough for you to pinpoint what's going on because it tells you where the things are happening, right? So the real problem is the thing I said. The real problem is that, I'm gonna get rid of this. The real problem is that when I take out this explicit run, we get a different problem. Now, I started putting in this explanation, and maybe we should detect this instead and divert it to this explanation. But the problem is, the reason I was having trouble finishing this explanation is because the reason we're getting here is because the compilation state is actually kind of broken. It's in a way that it shouldn't ever get to, whereas this is fine. So really, my problem is that the dependencies are going in the wrong place. They're probably, maybe they're going on to the if. If they're going on to the if, this might be easier to fix than if they're going on to the procedure. If they're going on the if, we just put all our dependencies there. Okay, I should be able to find where this happens. So this is at line 16, and if I go into here, this is not the right place. Okay. So if it's already a run directive, we wait for it to substitute. That means, like, the run directive puts a substitution value when it completes. If it's not completed, we yield. This is all fine. If it's not a run directive, see if it's a literal. If it's a literal, then it's trivial, right? If it's not a literal, here we make this run directive. And maybe I want to check the dependencies here, because it may just be that the static if needs to put its dependencies into the run directives lambda body header. I don't know. This is complicated. I want to look. I want to look at line. How do I even get the file I want? What? Go to line? Did they change go to line? Can I not? It's not Control G. Go to line 6355. What is wrong with this? Oh, it wants the colon there? Ugh, this program. Why did we upgrade? Why did we downgrade to Visual Studio 2017? I don't understand. Don't understand. Don't delete the colon. Of course you need the colon there to go to a line number. All right. So here, I'm going to say condition static. Is there a setting that I can change this back? Someone please tell me there is. Is there a setting to like fire the people who made the UI for Visual Studio? It's hard enough to debug complicated programs. I don't need all this stuff happening to me all the time. All right, let's make sure we're in the right file. File name repro, so that's good. So here we have a queued. It's got one dependency. The dependency is on get field. Okay, that is what we need to transfer. And that goes on the body. So let's just do it. Let's just do it. I mean, this is the kind of complexity okay. For static if dependencies, we have to do this lambda body queue dependencies dot add its static if dependencies dot reset. Oh. I hope we always who knows? Let's do this. Okay, what's the code? Hey, okay. Okay. So this is good. Hey, look, there's our circular dependencies. It'll be nice if we can actually write a library that draws this for people eventually, and the compiler can just draw it for you. It won't be frickin' GraphViz, because that program gives me high blood pressure, but you know, this diagram is more complicated than it needs to be. So maybe I'll just work on, I'm going to work on simplifying this a little bit, because we want better, nicer user reporting. Okay, so here definitely we have two cases of like, hey, header depending on body and body depending on itself for some reason. Header, body. So this would be have two fewer nodes. So it would be, you know, this lambda. We could say that this belongs to a run directive or something, right? One procedure, depending on one procedure, depending on a static if, depending on a run directive. Yeah, so we're going to flag this up and make it better. Make it better. Okay. However, before I do that, we're going to get rid of this, because this doesn't do anything right now. Sorry, folks, but it doesn't do anything. Okay, we found a legit, whoops, that's not what I wanted to do. We found a legit problem in the compiler that didn't have anything to do with what we thought it did, and that's good. Okay, so how do we make this message better? Well, first, let's get these unhandled types. 31 and 43, right? So, well, those are going to be in asked. So 31 is run directive and 43 is static if. Well, let's handle those. Case ask directive static if and run. Return. We're just going to keep it simple for now, and we're going to provide more information in a minute. All right. So now, well, this has a lot more nodes than we necessarily want. So what can we do? Well, first of all, this procedure is implicit in the static if, and so is that. And we can flag them as such. And maybe eliminate them. Right, so we've got all these explainer nodes, and we can collapse explainer nodes into other nodes. Yeah. When we create this run directive, do we flag it in some way? We don't. So we need to flag this anyway so that user code knows this is implicit. So we're going to make this flag created by desugaring, right? And then lambda. And then now we're going to use that to give people one more slight piece of information, which is going to be if implicit run made to evaluate condition of if. And then here, implicit procedure. Okay, so now we're going to at least say, well, these things have to do with that static if, right? There we go. Procedure to evaluate the if run me to evaluate the if and the if. Okay, so now if you're trying to figure this out, you have a better idea. Oh, this doesn't print the same nice strings. We would eventually make this print the same strings or something. This is better. Now, that said, you don't really need all this stuff, right? Question is there a way to map it back to the if? Like, we would like to say, hey, if you're depending on like the way the compiler handles this is this if depends on the run, and the run depends on the lambda. And we maybe want a procedure that says remap dependency. So we want to say if there's a static if, and it depends on its own implicit run directive, then remap that. Yeah, that's going to be good. So we'll do that. And, well, we'll also say if a run depends on its lambda, remap that. And we'll do those in the opposite order of how I said. And we'll do them one at a time. And at the end of that, we will have a much shorter and more understandable thing. And then we can do the header body thing. It'll be great. It'll be great. But first, I'm going to make a warm drink. Any questions about what I'm rambling about? Questions? While I heat up some water? Someone's playing Monkey Island. That's not a compiler question. A statement that someone is playing Monkey Island is very different. You don't have in-depth experience with low-level languages like assembly, C or C++. Which one of these would you recommend? My answer would be, what do you want to do? What's your goal? Like, what do you want the experience for? What tea is it tonight? It is Bengal spice and Mozart candies night. Fast multi-purpose networking and graphics. Well, C or C++, I wouldn't learn assembly for that, except, so the good thing about learning assembly is that you then have a model for what your higher level program is actually doing on the CPU, which like a lot of programmers these days don't have any idea about that. And that's part of why they're not very good programmers or can't write code that's remotely efficient. You don't really need to know assembly for that. It helps, but you can start just by understanding, if you look at the part of C or C++ that's about how structs are stored in memory, for example, and if you know basically how load and store instructions on the CPU work, that can give you enough of a general idea. So, C is simple. Less people use it now for complicated programs. C++ is less simple. You could just play around with one or the other of those, though. What workflows does our compiler team use for working together? I don't know that we have workflows. We just email, and, well, Abner and Josh call each other to talk about things. What are the intermediate steps? There's a whole video that shows those. I don't know if someone has the link handy. All right. So I want to make a thing that remaps. Let me get rid of that. I'm going to get rid of this. I'm going to say simplify graph Okay. So let's make sure that compiles. Small steps. Oh. Okay. No, still. Array explainer node pointer. That didn't go. Pointer. So hard sometimes. Would I recommend any book regarding C++? No. It's not really how I learned it. I learned it by, I don't know. I don't know how I learned it. It was a long time ago. Okay. So we are going to simplify the graph. And we're going to do one of these steps at a time. So we're going to say, if there is, this is going to be a very slow n squared thing, but of course our hope is that this graph isn't very long. We're going to say, if there's a procedure, no. We're going to say if there's a run directive that depends on its own expression, which is easy to detect, that's going to happen every time there's a run directive, actually. And we don't, the user shouldn't have to care about that because that's an implementation detail of the compiler. So we're going to eliminate that step. Actually, let's I'm going to make this thing called output before, right? So this is what we're starting with. And then we're going to have an after version. That'll be nice and small. This is our before version. So graphically, the link that we're going to eliminate is this one from the run down at the bottom to the lambda up here. We're going to combine those into the same node, right? So then, oh, this is going to be tricky. It's going to be, oh, maybe not. Okay, so yeah, so we're going to do that. So here's what we say. Simplify graph for nodes. I don't remember what an explainer node looks like or anything. Okay, it's got, yeah, 4 nodes. Eliminate the spurious information about a run directive depending on its own procedure, which of course it does. Okay. Wow, you know, Bengal spice, there's a lot of variance in how spicy any individual packet will be, and this one is pretty spicy. How big is our team studio currently? I think about 14 people, something like that. Something like that. Eliminate the spurious information about a run directive. Okay, so if it queued expression type is ask directive run and it dependencies dot items is 1 and it dependencies 0 target site target queued expression is equal to, well, so now the problem is we want to have casted something. We're going to say auto run is static cast directive run it queued expression, which we can do because we checked it right here. So it's equal to, a run directive has a lambda. So so if the one thing that this depends on, oh, you know what? Well, we'll do this later. Well, we'll do this. Because it might have more than one dependency for some reason. Well, here's the problem is we can't use these damn for loops because it makes it too confusing, because we're going to want to modify the node array, because we're going to remap and eliminate, but we won't do it yet. We'll say print found elimination. Make that real easy to see. Oh, it's a printf. Find the 10,000 things I did wrong. Let's see if we at least hit that and don't crash or something stupid. Hey, found elimination. That's good. That is good. We don't have an hour-long sidetrack of that not working. So we found it. Okay. I'm making this explicit because we're going to dork with the indices when we edit the array. I'm going to take a pointer to it instead of copying it. Okay, so that compiles, and then for int node index is 0, node nodes items. This is dangerous. If you type what I typed, it'll dereference the pointer and blah, blah, blah. Bad part of C++. Okay. If node, okay. It's this one. Whoa! I just hit some key in Windows that made the screen go black. And I don't know what that was. I hope my stream is still going. Yeah, okay, it is. There's so much complication in Windows. It's just, oops, that's not what I wanted. Too used to running the Sokoban game. All right, so we're still finding the elimination. That's good. That's good. Now we've got our explicit things. And we will say remap and eliminate in nodes, comma, depth target, and then this dependency will have gone away just to make sure. Oh boy. See, the problem with this is this is an unordered array, and we may remove someone from earlier in the array and miss it later. So here's what we're going to do. We're going to say while true, change do one simplify pass insert nodes. It's always scary to write an infinite loop, but there you go. Okay, so tool do one simplify pass. We are rearranging unordered arrays so we could miss something. Reordering. Thus, we call this many times until we stop changing, until we cease changing the graph. Changed is false, and we return changed. And then here, change is true. Okay, that's good enough for government work. So we'll do more than one of these in a loop if we detect it. Okay, let's make sure that still compiles and runs. Oh, remap and eliminate doesn't exist, so that doesn't do anything yet. Doesn't do anything yet. Well, now we're infinite looping. Oh, because we're not doing anything yet. Of course we're going to infinite loop because we don't eliminate anything. Let's just... Okay, great. So now we have to eliminate the thing. So for nodes, if remove target from array, we need to say what we want to replace this by, and we're going to replace it with node. Right? Node is the run directive node, and this other one is the lambda. So we should just be able to say nodes.remove target, right? Something like that. Can't type today or any day, really. All right. Didn't remove it. That confuses me. That confuses me. Okay. I think I have my desktop audio turned off so you guys aren't hearing the wonderful Windows beeps. So what is nodes? 401 items. Oh, this isn't... Right. Right. Okay. First of all, it still should be working, but because I'm going to be dorking around with this thing and making changes, I actually want to make a copy of, I want to make a subarray of, because remember we had this big group of nodes and then we found a circular dependency in there. So I want to copy that thing. Because, you know, we may want to iterate through this higher level group of nodes and find several circular dependencies. And I think that if I modify globally it's less clear. It's less good. So all. Okay. I'm calling simplify in the wrong place, really, actually. So blah. Okay, this is annoying. This is annoying. Okay. Okay. This is all still fine. It's not that big of a difference. So I'm going to say over here, I'm just going to say array explainer node to print, and I'm going to say so we're not going to set the printout index yet because we're going to do this simplify onto print, and then we're going to say the printout index is just, yeah. And then this, this is not nodes, this is to print. This is to print. And this is the same. Great. Great. I gotta move this up because we're in C++. Oh, and I gotta move this up because we're in C++. And I gotta move this up because we're in C++. I can't believe it's 2018 and we're still doing this. And I can't believe we're in 2018 and I'm still spilling tea on my shirt. Oh, you do hear the Windows sounds, okay. Okay. Well, what did we just do? Well, we still didn't remove it, which is weird. But now we should have a small array, not of 400 items, right? 8 items, that's much better. Hold on, I now have a serious T problem. Why do I think they call them T-shirts? That is a good point. That is a good point. Okay, so let's make sure we have the right target. This should be a lambda, right? targets, site, oh, the site, target queued expression type. Yeah, that's the lambda. Are we calling remap and eliminate twice somehow? I bet we are. Yeah, because we're looping. Okay. I bet we're asserting because we're calling this twice. And we're not removing the dependency yet. First time, second time. Okay, so even though we're asserting this is correct, the reason we're getting to this the second time is because the dependency is still there, and we have to get rid of that. So, step 2, remap any dependencies to the replacement for all the nodes. What does an explainer node look like? For dependencies item dependencies I need to take a pointer because I'm modifying it. If dep arrow queued expression, no, dep arrow target is equal to target, dep arrow target equals replacement, dep arrow target queued is replacement target queued. Incomplete, we may already have this. Right? We might be making a dependency to something that's already there. Target queued is not a member of explainer node. Yeah. Let's see what happens there, bro. Hey. Okay. I think that actually worked. Look, it's simpler. Well, except the run directive doesn't depend on get field. That's wrong. Why not? Oh, so we missed a step. Step 3, put all dependencies of target into replacement. Oh God. You know, I was saying that I didn't want to globally do these modifications. But whatever, we're just getting it done, and then we'll see if we want to do it nicer later. Yeah, we're destructively modifying these guys. So, check for duplicates. Okay. For target dependencies. If it dot target target continue replacement dependencies dot add it. All right. Okay. Okay. So we have a simpler thing. My mouse still has liquid on it. And I don't mean liquid, the esports team. So I don't know if this Microsoft program has the technology to show 2 bitmaps at once. But, you know, we have output and then output before. Oh, yeah. Nope. It just, can I like go, how do I go to the last picture? The old frickin' photo viewer would, oh no, here we go. It's, okay, we have 2 windows. We do have 2 windows. All right. Here's the before. And here's the after. Now we're not done with our after. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. We are 1 node less now after all that. Do I expect these types of changes to live for the lifetime of the compiler, or are you expecting this to be a temporary solution until something better is found? No, this thing that I'm doing right now is a long-term thing, because the compiler is always going to have implementation details of how dependencies work that we don't want to expose to the user when we're trying to explain to the user what's going on. So this simplification step that we're doing is always going to exist. It might end up doing different things, but it'll always be there. All right, so this was a run depending on its own lambda. That's gone. Now we want an if depending on its own run. We want to simplify that out as well. So we're going to keep this one up. The before is not going to change. Okay, so now that we've got this stuff, we should be able to do other cases, right? So we should be able to say, well, if it's not a run, maybe it's a static if, right? And then we'll do a similar thing. Static if is, right? And then this. And if it depends on, I don't remember. If it depends on its condition, this is very similar to what we just did. Like, we might be able to factor that into something higher level. See what that does. Hey, it looks shorter. That's even simpler. Look at that. Look at, here's our before. Here's our now. It's getting better, right? So, we'll make a thing, let's make a thing that eliminates self-dependencies now, because the compiler might generate those for some stupid reason. We'll eliminate self-dependencies, and then we'll eliminate this double dependency. And then we'll do this thingamabopper and this thing. It's going to be so good by the time we're done. It's going to be so good. So see how the printout is getting better, except for the double dependencies? All right. These incompletes, if we already had this step, if we already right here. Okay, remap and eliminate, blah, blah, blah. Do one simplify. So to print, we're going to say simplify, okay, simplify graph. Eliminate self-dependencies for nodes. If it target is equal to node array for each remove current element node dependencies. Continue. Yes, that is a long ass macro name. 837. Eight, 3, 8. Wait, what? I think this macro is maybe not. I think it wants the pointer. Oh, for a programming language that. Oh, this is right. This for is a different. This uses a C++ iterator, and it's not so straightforward to remove things. Yeah. Okay. Okay. I've got a different macro for that. Yay. This is the older one. All right. Let's see if that works. Where did our window go? It's not even popping to the top windows. Okay, this is interesting. It didn't do anything. Let me look, let me make sure that those are what I think they are. So, wait. It's not. Because our printout here doesn't have these self loops. Right, so 0 is the if, and this assert depends on 0 twice, so that's this guy. There might be a difference between what I print and what I put in the file. Yeah. So we're working right now on what we print. So I'm actually not going to worry about these arcs because we don't print them. Later when we bring this more in line with this, we'll get rid of those. But this thing is, so now we have to get rid of duplicate dependencies. 1 J. If call them dep I and dep J, and if dep I target is dep J target, then, well, if that's the case, then we get rid of J. So and there, something like that. Uh-oh. J equals I plus 1. Okay, I screwed something up here. Oh, we've got to reduce the number of items. Duh. Duh. Come on. Come on. This ain't no amateur hour. All right. We got rid of our double down there. Now it's a single. Hey, look at that. So now, if we have a header, depending on a body, I guess it doesn't matter, but we'll subsume the header into the body. Yes, I look at the chat and name guy says, you forgot to decrement the dependencies items count. Yes, I did. Yes, I did. Okay. Okay, we're getting real close. Getting real close. Okay, well, let's go to our single simplify pass. And you know, I should have done this years ago, because in the early days of debugging the compiler, I was just staring perplexed at all these dependency graphs, and like, this is just going to make it way better, I think. I saw a bubble in my tea that somehow had formed, and I was like, oh my God, is there a bug in there? What's going on? All right. So, if node queued flags and what was it? Is it queued flags or is it flags? No, it's just flags, and it's is lambda header. So remap and eliminate. And we'll eliminate the header. Because we're going to eliminate the header, whoa. I think we're okay. I don't know. Like, we're iterating over this thing that we're modifying. If it's... It should be okay. Yeah. All right. Remap and eliminate the node with right, so we're doing it in the opposite way of usual. Let's see what happens. Well, that looks simpler. Doesn't look like it hit everything though. Oh, because we have declarations, I think. I may have done the wrong thing. Right, okay, this isn't a lambda depending on a lambda anyway. Duh. This is a declaration depending on a lambda, which is... So since we're not using this right now, we'll comment it out. But what we really want is very similar, right? So it's like, hey, you have a declaration of something. It's blocking on the value. The fact that the compiler is very picky about that is sort of a trivial thing that doesn't help you understand. So okay. No, let's not even check that. Let's just do this. No, let's check it. So if it's got an expression, if that's the declaration's expression, we're going to eliminate the declaration. Yeah, we're going to eliminate the declaration. Okay, that's similar to what we did, but instead of lambda header to lambda body, it's declaration to lambda, right? So whatever. Hopefully I did the right thing. Hey, that looks simpler. Wait, no, it doesn't. Oh, wait, no, we did. We did have header body. So we have to do both of these. I don't, okay. So here's where we're at now. I think, was that old? I've got old ones floating around. All right. I may have been confused a minute ago by viewing an old one because it doesn't pop the window up when I do this. Like it's just the window's underneath somewhere. Okay, whoa, oh, this is where we're at then. Right, so the thing that's confusing is this different view That's the programmer debug view, is already doing the header body collapse, I think, and this one isn't. So let's turn that back on. Anyway, you can see I don't know why we're drawing this. That's weird. Anyway, let's see where we're at here. Okay. Remember way back when we had that really long, I should have saved the text. We had really long circular dependencies with like 9 items, right? So now we're down to, well, procedure made by the if. I don't know why we're not eliminating that. We're supposed to be. Get field. So get field depends on the assert. Assert depends on if. Never mind that this is jumping around. We can sort this later so it doesn't frickin' jump around as much, right? So get field depends on the assert. The assert depends on the static if. The static if depends on its own procedure. That step is the one we don't need in the procedure, blah, blah, blah. So the question is, weren't we eliminating this before? Like, when did it come back? Maybe, I don't know. I don't know, man. Keep zooming into that circular dependency and enhance to get to the line that causes the button. Yeah. Enhance, that's the button we need. That is the button. I wish I could enhance Windows, really is what I wish. Okay. So I guess we were never getting rid of that. I mean, if I look at this one, we're much better now. Look how much better now we are, but we still have this arc. We shouldn't need this. We want to end up with a triangle. We want to end up with get field depending on assert, depending on the if. So the if depending on the lambda is not firing. So let's go there. So if it's a static if, we're going to look at every dependency. Okay. Def, target, queued, expression. I can't type. Okay, it is the same pointer. We're supposed to eliminate. Oh, but that's the run directive. That part's working. Okay, the problem is we're eliminating the run directive. We're eliminating the run directive before we eliminate its lambda. So the collapse is working, it's just, we're killing that. So as a low-hanging fruit, We could just do this in 2 passes. I don't know. I don't know. I don't know. Yeah. We're going to do an ugly hack for now. We probably will want to generalize this later. Before we could clean this up by sorting the nodes by collapse priority or doing something else. Okay. We just have to make sure to look at all the run directives first. Hey, we have 3 things. Okay, this is it. This is what we're looking for. Look at that. For the same problem, you can either try to figure out what the hell is going on there, or you just look at this. Look, get field has assert, and assert has an if, and the if is get field. Look, that's what's happening. That's what's happening. It's like the compiler is helping me understand. The condition of the if depends on get field, which depends on assert. Then, let's make sure Sogomon still builds. Boy, that debug build is sure taking a long time. Now, I gotta run this. So we upgraded to LVM6, and I think the debug build of that is especially slow. I think Casey and I have different ideas of what we would want in an OS, so I'm not sure how that collaboration would go. All right, well, Sogomon built. I'm a little scared to run the tests. Wait. I guess I have to run this from there. Procedure is deprecated. Debug builds. All right, well, we pass all the tests. That is good. That is good. I'm going to commit, and I'm going to say filter circular dependency reports for much better intelligibility makes the user side problem in bug 103 understandable. That was decent. That, oh God. Okay. That was quality. And with that, I think we're going to end the stream. Are there any ending questions about what happened there? Well, we'll do some more streams later. Don't worry about it if you just got here. You know, can't stream 24 hours a day. I would die if I did that. We'll probably do some more compiler bug streams. That was bug 103. We have to go up to bug 115, but hopefully many of the rest will be easier to deal with. What would my long-term solution be for the hack? I don't know. I could vaguely think of several things, but the whole point, the whole reason it's a hack is because I don't know the right answer. Because the right answer depends on what other kinds of node simplifications go in that procedure. If the answer is hardly any more, then the hack is fine, right? You don't want to build a more complex system for doing something if it's not necessary. So we're just going to see. Like I said, the dependency systems are going to get rewritten. It may or may not affect that part of the code. Implementation details will change, and we'll just see, right? For current purposes, that solution was fine, and we'll just see if it's different. Have I seen Monster Hunter World? The Monster Hunter games don't appeal to me. I've been playing a lot of PUBG lately. Am I still working on Sokoban? Yes, I just worked on it a whole bunch for the past several weeks. Just didn't stream any of it. Am I still leaving the question of semicolons till the end, or have I made up my mind? I think there probably are semicolons. And the reason is that when you have semicolons, you can auto-indent very easily. Okay. There's two related but separate issues, right? One issue is, does your grammar have semicolons? And the other issue is, does it have significant white space? Like, does the indentation determine the nesting? And I think, so like in languages like Python, and I think the answer to that is no, we're not going to have significant white space in any version of this language, because just pasting a code of block and pasting a block of code and then just telling your editor to indent it is super useful. However, Go does this weird thing where, a carriage return acts as an implicit semicolon under many conditions, but not all. And we might do something like that. It's just, I'm given to understand that the Go version causes problems in some cases, and I'm not very familiar with that. So the Go version of implicit semicolon, I would say, is on the table maybe vaguely, but if we don't do it, I wouldn't be very sad, because semicolons are fine. But, more research is required. All right, everybody. I'm going to take a break, and then maybe I'll do some gaming. I don't know if I'll stream it. Maybe I'm just going to do some tired PUBG. Thanks for coming by. I don't know anything about chess. See y'all later.